Morning students, welcome back to the Science 1 class. Today we are going to learn Unit 3 Fluids. First of all, let's see what is meant by fluids. The states of matter that can flow due to less intermolecular force of attractions or liquid and gases are called fluids. In this lesson, you will study about pressure in fluids, density of fluids, and the applications in practical life. Before we are entering into this lesson, let's understand what is thrust and pressure with an example. As you see in daily life, you are pushing a box, your weight, which is a force acting downwards, hammering a big nail into the ground. All these forces, if you notice, are acting perpendicular to the surface. A force exerted by an object perpendicular to the surface is given a special name. It's called thrust. Is the total force acting perpendicular to the surface. What will be the unit of thrust in the SI system? The SI unit of thrust will be the same as that of force Newton. The SI unit of thrust is Newton. Next, what is pressure? I want you to understand it. Let me give you a couple of examples. Take a pencil and keep it between your thumb and index finger with the tip touching the index finger and the other end touching the thumb. Now apply equal force from both ends toward the pencil for a few seconds. Release the pencil and observe the two fingers. To be precise, observe the depression you see in the finger. You notice that the depression in your index finger is much more as compared to the depression in your thumb. Why does that happen? Before we answer that, let me give you a second situation. When you stand on loose and you see that your feet go deep into the sand. Now, if you lie down, the sand will you go just as deep into the sand. No, you won't. But if the force exerted in both cases in the weight of your body, then why is the depth in the first case more? That's where the concept of pressure comes in. Pressure is nothing but the force per unit area. If we're talking about thrust, it would be the thrust per unit area. If the thrust is constant and the area is more than the pressure, it will be lesser, and if the area is lesser than the pressure will be more. Pressure is inversely proportional to the area on which the thrust is applied. Now we can understand the two situations in this formula. What happened in the first situation? As we apply an equal force from both ends, the laws for the Newton's third law, the pencil will also apply an equal and opposite force. On the fingers, the depression was more on the index finger. That's because the area on which the tip of the pencil applies a force on is lesser as compared to the area on which the other end of the pencil applies a force on us. The area is lesser, pressure is more, and that's why the depression is more. Can you understand the second situation? Using this concept, in the second situation, the area on which your feet lies lesser as compared to the area on which your entire body lies, and that's why the pressure is more when your feet are on the sand as compared to when your entire body lies on the sand, which explain why the depth here is more. What is the SI unit of pressure? As its force over area. It would be Newton per meter squared. This is the SI unit of pressure and this is also called Pascal. 1 Pascal is equal to 1 Newton over 1 meter squared. This would be named after a famous scientist called Blaise Pascal who had conducted extensive studies in this area of science. Next, we will see pressure in fluids. All the following substances, both liquid and gases, are called fluids like solids. Fluids also have weight and therefore exerted pressure. When filled in a container, the pressure of the fluid is exerted in all directions and all points of the fluid. Since the molecule of a fluid are in constant rapid motion, particles are likely to move equally any direction. Therefore, the pressure exerted by the fluid acts an object from all directions. Fluid pressure is calculated by total force exerted by the fluid divided by area over which the force is exerted. That means P is equal to F by A. Next, we shall learn about pressure due to liquids. The force exerted due to the pressure of a liquid in a body submerged in it and walls of the container it always perpendicular to the surface. We can see the pressure acting on all sides of the vessel in this picture. Now we will see liquid pressure exerts force upwards. When an air-filled balloon is immersed inside water in a vessel, it immediately comes up and floats on water. It shows that water exerts pressure in the upward direction. That's why it comes up. Okay, next we move on to lateral pressure exert force up walls of the container. Similarly, liquid pressure acts in lateral sides also. When a bottle having water is pierced means hole on the sides. We can see that water is coming out. This is because liquid exerts lateral pressure on the walls of the container. So first we talk about lateral pressure. Lateral pressure means in one horizontal space. If we are talking about height h in a liquid, lateral pressure is the pressure exerted by the fluid on the sides of containing vessel. Pressure is directly proportional to height of the fluid and density of the fluid. This statement is important. To understand this statement, more the height, more pressure. Lesser the height, lesser pressure. That's why pressure increases with depth when we move inside for diving. That's why the divers wear specially designed suit because to withstand pressure inside. So pressure increases with depth. So pressure is directly proportional to the height of the fluid and density of the fluid. So density and height both are directly proportional to pressure. If density of the fluid will increase, pressure will increase. The density will decrease, pressure will also decrease. Depth will increase, pressure will increase. And depth will decrease, pressure also decrease. Next, we will see the factors determining liquid pressure. Pressure exerted by a liquid at a point is determined by depth. It is denoted as h. Density of the liquid, it is denoted as rho. Acceleration due to gravity, it is denoted as g. Pressure due to liquid column. Take a small tall beaker filled with the liquid so that it forms a liquid column. Okay, so the area of cross section at the bottom is capital A. The density of the liquid is rho. The height of the liquid column is h. In other words, the depth of the water from the top level surface is h. We know that the thrust at the bottom of the column F is equal to weight of the liquid. Thrust is equal force, force is equal to thrust. Okay, what is the formula for force? F is equal to mg, mass into acceleration, gravity. If we want to find out the force, we have to know mass of the liquid. So we can get the mass of liquid by multiplying the volume of the liquid and its density. So first you need to find out the mass of the liquid. What is the formula for mass? M is equal to rho V. M is mass, rho is density, V is the volume. Now we have to find the mass of the liquid. So how will you find the mass of the liquid? Mass of the liquid is equal to density into volume. You have to know density and what is the volume. Volume of the liquid column V is equal to area of cross section capital A into H is equal to AH. So multiplying these two only we will get volume of the liquid column. So when you multiply what is the volume of the liquid column A into H, you take that is equation number 3. Now substituting 3 into, okay, we get what is the second equation? M is equal to rho V. Hence mass is equal to rho AH. This is equation number 4. Now substituting equation 4 in 1. You already know that force is equal to mg. That formula we are going to substitute the fourth one. Force is equal to mg, that is rho AHg. Now we want to find out the pressure. What is the formula for pressure? P is equal to thrust F divided by area is equal to mg divided by A. So substituting the mass here, rho AHg divided by A. A get cancelled. Now finally we get P is equal to rho Hg. Pressure due to liquid column is equal to rho Hg. This expression shows that pressure in a liquid column is determined by depth, density of the liquid and acceleration due to gravity. Okay student, that's all today's class. Thank you. Have a nice day.